Now passing on to the last topic of section 6.9, which is to find the foot of the perpendicular from a point whose position vector is u vector to the plane r dot n is equal to p. Okay, so let us see the formula. The point will be given. From the point you can take the position vector, or directly the position vector also may be given. So the position vector of the point is taken as u vector. So the formula is foot of the perpendicular is u vector plus p. You know r dot n is equal to p. From there you have to identify what your p is. P minus u dot n, that is the point, position vector of the point, dot n, the normal to the plane n. From there you have to identify what is your n. So p minus u dot n into, this is ordinary product, into n vector divided by modulus of n square. So this is the foot of the perpendicular. Actually this will give you a vector. From there if you want the point you can just convert it into the point and give the answer. So the foot of the perpendicular is from the point whose position vector is u vector to the given plane r dot n is equal to p is, the formula is u vector plus p minus u dot n into n vector by modulus of n square. So let us now try to apply this in a problem. The problem from the exercise, problem number 8. Find the coordinates of the foot of the perpendicular and length of the perpendicular from the point 4, 3, 2 to the plane x plus 2y plus 3z is equal to 2. So here the coordinates of the foot of the perpendicular and length of the perpendicular from the point. So the point, from there you can write what is your position vector of the point. So here u vector is equal to, so here u vector is equal to, from the point you can write this as 4i vector plus 3j vector plus 2k vector. Is it not, from this? And then what about your n vector? The plane is given in the Cartesian form. So from here also you can identify what is your n. So n vector is equal to, convert it to I, j, k. So 1 into I, so I, plus 2 into j, so 2j, and then plus 3 into k, which is 3k. Is it okay? 1 into I plus 2 into j, so 2 into j plus 3 into k. This is your n vector. And what about your p here? R dot n is equal to p. So this is your p. So p also, p is equal to 2 because you need that also here. So once you have identified what are all needed, you can just substitute here. So for that, what do we need? Let us find what all we need, then substitute it here by writing the formula. So u dot n. So what is u dot n? The dot product with these two vectors. So I with I will be 1. So 4 into 1. So it is 4. And then j with j will be 1. 3 2s are 6. So 6. And then k with k is 1. 2 3s are also 6. So 6 plus 6, 12. 12 plus 4, 16. So this is your u dot n. Then what do you need? After u dot n, you need modulus of n vector and then its square we need. So modulus of n vector, the modulus of this vector, which is root of I coefficient square, which is 1 square, plus j coefficient square is 2 square, which is 4, plus k coefficient square is 3 square, which is 9. So 9 plus 1, 10 plus 4, 14. So it is root 14. If modulus of n is 14, I want n square. So therefore, modulus of n square is equal to root 14 the whole square. So which is equal to 14. So now we have found modulus of n square. We have found u dot n. And then you know what is p also. So you can now go to the formula. Okay. So now write the formula. Now this is a problem, so write the formula. The foot of the perpendicular is, the foot of the perpendicular is equal to, so u vector plus p is not a vector, p minus of u dot n into n vector divided by modulus of n square. P is the constant here, 2. So now this is equal to, let us now substitute your u vector. What is your u vector? 4i plus 3j plus 2k. This is your u vector. Okay. 4i plus 3j plus 2k plus p. What is your p? 2. Minus u dot n, we have found here u dot n is equal to 16. So 2 minus 16, that's within bracket. Okay. So 2 minus 16 into n vector. What is your n vector? Substitute that. So into I vector plus 2j vector plus 3k vector. And then this by n vector is only for this term. So divided by n square, which is 14. Is it okay? So this is equal to 4i plus 3j plus 2k minus, because 2 minus 16 is minus 14, so plus of minus 14 is minus 14 into I plus 2j plus 3k, the whole divided by 14. Is it okay? So plus of minus 14, 2 minus 16 is minus 14, so plus of minus 14 is minus 14 into this. Now 14 and 14 will get cancelled, so you can write this is equal to 4i plus 3j plus 2k. Now minus of, so it will be minus I and then minus 2j and then minus 3k. Is it okay? So what is 4i minus I? 3i. So 3i vector. 3j minus 2j will be j plus j vector plus 2k minus 3k will be minus k vector. So this is your foot of the perpendicular. Now this is the position vector of the foot of the perpendicular. So it's better we give the foot will be a point. So you can say therefore the foot of the perpendicular is in the point form. The foot of the perpendicular is 3, 1, minus 1. If you put in the coordinate form, it is 3, 1, minus 1. Is it okay? Now there is another part of the problem. We are asked to find the length of the perpendicular from the point. So what is the length of the perpendicular from the point? The formula is d is equal to modulus of ax1 plus by1 plus cz1 minus d by root of a square plus b square plus c square. We know already. So for this problem, what is your a, what is your b, what is your c, what is your d, you have to identify. So from the plane, so this is your a 1 and then b 2, c 3 and then your d is also 2. So a is 1, b is 2, c is 3 and your d is 2. So we can substitute that, and also x1, y1, z1 is this. 4, 3 and 2 is your x1, y1, z1. So here you can write. So here a is equal to from the plane 1, b is equal to from the plane it is 2 and from the plane c is equal to 3 and d is equal to 2. So a, b, c, d are identified from the equation of the plane. So 1, 2, 3 and 2. So 1, 2, 3 and 2. And then x1, y1 is the, z1 is the point. So x1 is equal to 4, y1 is equal to 3 and z1 is equal to 2 from this point. 4, 3, 2. Okay. Now you can substitute it. Therefore, d is equal to modulus of a 1 into x1. So 1 into 4. Is that okay? And then plus b. What is your b? 2 into y1 is 3. And then plus c. c is 3 and z1 is 2. Okay. And then minus d. So minus d is 2. So 1 into 4, a into x1 plus b into y1, 2 into 3 plus c into z1, 3 into 2 minus d. So minus d is 2 by divided by root of a square. So 1 square is 1 plus b square 2 square is 4 plus c square is 3 square which is 9. So this is equal to 1 4s are 4, 2 3s are 6, again 3 2s are 6 minus 2 by root 9 plus 1 10 plus 4 14 which is equal to, so 6 plus 4 10, 10 plus 6 16, 16 minus 2 is 14. So it is 14 by root 14 and it is already positive, so modulus also will not change the value, so it is 14 by root 14, so it is equal to root 14. 1 square root will get cancelled, which is the length of the perpendicular. Is it okay?